All right, welcome back everybody. Today we're going to spend some time talking about standard FP6, which is factoring binomials. Now when I say factoring binomials, what I mean is factoring something that only has two terms to start. Now the way this process goes is sometimes you get a really easy problem where all you need to do is factor out a greatest common factor. Other times you're going to have to do a little bit more work. So when I get to something that just has two terms, I always want to think to myself, is there a number that goes into each of these? And in this situation, I know that 3 goes into 6 2 times, and 3 goes into 3 1 time. So I'm able to factor it in this manner. Now, if you notice in this particular problem, there's no x squared here. So that's a guarantee that we're not going to be able to go any further, and that this will be my final answer. Let's look down at problem number 3. So looking at problem number 3, now we can do a little bit more. Now this is where you wanted to go back to your box, right? You could definitely do that. And you just need to think to yourself, well, what number can I pull out of 14 and 21? And that'd be, of course, 7. And in this situation, I can pull out two z's. So that would mean that this is a 2z up here and a minus 3 over there to get us back. So my final answer would be 7z squared times 2z minus 3. Now, the box is like a structure. You don't have to use it, but you have to be able to arrive at this answer, right? And that's just figuring out what's the biggest thing I can divide out of each of those, and what would be left if I did. I could also have gotten to that same answer by just looking at 14 and 21 and saying, well, I know I can pull a 7 out of each of those. And then looking at the z's and saying if this one has 3 and this one has 2, I can take out 2. And then looking at this whole problem and saying if I were to divide 7z squared out of this, I would be left with just 2z. And if I were to divide 7z squared out of this, 21 divided by 7 would leave us with a minus 3, and there'd be no z's left. So we get to the exact same answer regardless of how we do it. The box is just a way to structure your thinking. Let's look at problem number 5. Now this one looks completely different to me. And the reason this one looks different is because of this little exponent 2. Whenever I see that x squared up there, we need to think about the problem through a different lens. Now, when I see that, what that means is that I could come over here and introduce a 0x in between those two terms. Right? We always like our x's to kind of decrease from left to right. Now, when I do that, that makes us into a whole different problem, one in which we can use the x. So remember, we would take 1 times negative 9, that would go up top, and the 0 goes on the bottom. On the sides, we're going to have 1x over and 1x over. We just need two numbers that multiply to give us a negative 9 that are going to add to give us 0. Well, two numbers that multiply to give us negative 9 that add to give us 0 would be a negative 3 and a positive 3. So when we come over here, our final answer will be 1x minus 3 and 1x plus 3. Now, personally, I think probably the most confusing part about this is that it's always hard to know which step you should be doing next or what type of problem it is. And that I understand that frustration altogether, but it really comes from practice and just looking at it. The way I always start is I always start by looking to see if there's a greatest common factor first. And then once I pull that out, I like to look at it and digest it and say, does this look like anything I've seen before? So looking at problem number 7. Now, in problem number 7, I look for a greatest common factor, but unfortunately 4 does not go into 25, and there's no number that goes into both of those. So if that's the case, since I do have a squared variable here, I can introduce the plus 0c that's missing in the middle. Now, at this point, this actually looks more like an x problem than not. So let's try to factor it that way. And notice how I said try. Sometimes you just try something and you realize that didn't work. We got to go a different route. Remember, to get the top number, 4 times negative 25, that gives us negative 100. The bottom number will be 0. Since our a term is 4, we're going to have 4c over and 4c over. Now, we're just looking for two numbers that multiply to give us negative 100 that add to give us 0. Well, how about a -10 and a +10? You want to come over here and reduce these like fractions if possible. So this would become 2 over 5, and same on this side, 2 over 5. So my final answer here would be 2c minus 5 over 2c plus 5. And this would be my final answer, right? So I started by looking for a greatest common factor. If it wasn't there, I tried to add in that missing term. Sometimes it'll make sense to do that, other times it won't. And then I just factored like I normally do using my AC method, which again is AC over B, and then this is AX over and AX over. So let's go to problem number 9. Again, I look for a greatest common factor, but there's no number that goes into 9 and 4. So what I want to do is I'm going to try to put in my missing term. So minus or plus 0x minus 4. Now let's try to factor it using the x. So again, I take my a and I multiply it by my c. 9 times -4 is -36. 0 is going to go on the bottom. Since my a term is 9, I'm going to have 9x over and 9x over. I'm just looking for two numbers that multiply to give us -36 that add to give us 0. Now, one trick I haven't told you about is that if your numbers add to give you 0, the only way that can happen is if they're the same number but opposite signs. So I know that 6 times -6 would give us a -36, and then 6 plus -6 would give us 0. So at this point, always look to see if you can reduce. I could make this into 3 over 2, and same with this. So I could rewrite this as 3x, and this is positive 2, so plus 2, and 3x minus 2, which will make this my answer. Great job. Let's look at problem number 11. So in problem number 11, notice how I know 2 goes into both of these. So I'm going to be able to start by pulling out that 2 out of each of those. Now, since I still have an x squared inside, I'm going to try that trick of adding in the 0x. So I'm going to have x squared plus 0x minus 4. And I'm just going to try to factor here. Maybe it'll be successful, maybe it won't. So remember our a term is 1, so 1 times -4 means we'll put a -4 on top of our x. 0 is going to go on the bottom. On the side, I will have 1x over and 1x over. I just need two numbers that multiply to give us -4 that add to give us 0, which in this case would be a positive 2 and a -2. So at this point, like I've always said, come over here, reduce if possible. We can't in this one, so we'll have 1x plus 2, and we'll have 1x minus 2. Now, we did have this 2 in front, so don't forget to put the 2 in front over there. Nice job. Let's look at number 13. So this is a weird problem. And the reason I say it's weird is because normally I like to have that x term or that x squared term in front. So let's actually move it in front. So minus 4x squared, right, because the minus goes with that number, and then this is a positive 25, so I couldn't say plus 25. These two things are exactly equal to one another. They didn't change. We just flipped the order around. Now, when I look at this, one thing I hope that's jumping off the page to you is this negative. We don't ever want that leading term to be negative. So if it's there, we need to try to divide a -1 out of everything. So if I were to divide a -1 out, -4 divided by a -1 would leave us with a positive 4x squared, and positive 25 divided by a -1 would leave us with a minus 25. Now, at this point, let's try to factor this. So we're going to add in our missing term, that's 0x, like we've done for a lot of these other problems. So coming over here, my top number is going to be a times c. So 4 times -25, which will give us -100. Our bottom number will be 0. On the side, I'm going to have 4x and 4x. I need two numbers that multiply to give me 100, that add to give me 0, which would be, how about negative 10 and positive 10? Now, of course, we can reduce these right now. 2 goes into 4 2 times, and 2 goes into 10 5 times, and that'd be the same on both sides. So I can make my final answer, I'll have that negative 1 out front still, and then it'll be 2x minus 5, and then it'll be 2x plus 5. Definitely probably the hardest problem with the details in there that we've seen thus far. That's definitely like a level 4 question in terms of difficulty. But it's doable if you know the steps to make. Let's look at number 15 here. So number 15, we're always going to start by looking for a greatest common factor. So what's the biggest number that goes into 12 and 8? I think 4 does. So I'm going to be able to pull a 4 out of each of those for sure. Now, if I notice, both of these terms have at least one x. So I'm going to be able to pull out as many x's as the smallest one has. This one had 2 x's. This one only had 1. So that's why I'm going to be able to pull out 1x. Now, if I notice, they actually both have y's as well. This one has 1, and this one has 2. So I can pull out as many as the fewest one has. So I can pull out 1y from that. Now, let's see what we're left with. So 12 divided by 4 would leave us with a 3. I started with 2 x's, I pulled out 1, so I only have 1x left. I started with 1y, I pulled out 1y, so I don't have any y's left there. Now we go to the next term. Negative 8 divided by 4 would mean we're left with a negative 2. We started with 1x, we pulled out 1x, so we don't have any x's left. We did start with 2 y's, and we pulled out 1y, so that means we do have 1y left over here. Now, at this point, notice how I have two different variables. I don't have a squared variable. This is a great spot to stop. We can't go any further with this because of what we're left with. Notice how in the other problems, after I did that, how I had that x squared. That x squared, or variable squared, is a good spot to sit there and tell you that you can introduce that 0. But if you don't see something that's squared, this one had a square, we introduced it. This one had a square, so we introduced it. This one had a squared, so we introduced it. This one had a squared, so we introduced it, right? If we don't see anything squared inside, then we don't introduce anything new and we can't go any further. Thank you guys so much for watching this full video. If you have any questions, please do not hesitate to reach out. Remember, I'm always here to help you figure out what you need to. Thank you so much for watching. Have a great day.